Welcome to Chapter 4, Section 6, Perform Operations with Complex Numbers. All right, first of all, let's talk about what a imaginary unit I is equivalent to. What happens is you just got done working on the fact that x squared equaled 4. And you square rooted both sides, and you saw that x equaled positive or negative 2. But there comes a situation where if you had x squared equaled negative 4, right? And the situation here dictates that yes, you square root both sides, and you say to yourself, when you see x squared, or I'm sorry, not x squared, but x equals plus or minus the square root of negative 4. Well, this is a non-real answer. Non-real answer. And so there's no way to actually do this. So instead, they came up with there is a imaginary number set, meaning they came up with a set of numbers that where you could actually do this. And so what I is equivalent to, I is equal to the square root of negative 1. So basically, using the a product property, hopefully you remember that the product property of A, B could be the square root of A, square root of B. And so what you do is this right here, this negative 4, you break up to, you end up with plus or minus the square root of negative 1 times 4. All right, all I did was break up the products. So you'd end up with the square root of negative 1 and the square root of 4. And if you look now, since they came up with this, I is equal to the square root of negative 1, that means this right here is I. And the square root of 4 is 2. So this answer right here ends up being your positive or negative 2i. Basically, what you're going to do is anytime there's a negative inside of a radical from now on, you're going to take out the negative and turn it into an I. That's the basics of it. I tried to explain a little bit of why, but this is basically what you do. Oh, a complex number is a number with a real number and imaginary together. Okay? So an imaginary unit is this. An imaginary complex number takes the form a plus bi. The imaginary number part is the bi part. All right, complex conjugates. This is a key word here, conjugates. Complex number. So basically, you're going to have a plus bi. That's one part of the conjugate. The other part of the conjugate is a minus bi. Okay, just like the conjugate definition from before, identical expression except for a sign. So one sign is different. All right, the complex plane. This is talking about a coordinate plane. And usually we have an x and a y. That's what you're used to seeing. But the complex plane, let me move it to the other side, gives you the exact same thing. You have a vertical axis, horizontal axis, but instead of x, you have a real part and an imaginary part. So when you're looking at the number 2 minus 3a, or not 3a, 2 minus 3I, you could probably guess that the imaginary part is at, or the real part is at 2. The imaginary part is at -3, and so you could plot a point that is imaginary. The absolute value of a complex number, a plus bi, is equal to the square root, excuse me, is equal to the square root of a squared plus b squared. So it's the absolute value of a plus bi is equal to a squared plus b squared. So if you had 2 minus 3i, you would then find the absolute value by doing 2 squared plus -3 squared. And this just tells you the distance a complex number is from the origin. All right. All right, so some of this stuff we already know. We know that if r is a positive real number, property is negative number. So remember, I is the square root of -1. And so we saw an example of this. You take the negative out, and then you leave r alone. So here, take the negative out, turn it into an I, and you have I square root 3. Now, if you somehow square this, you would end up with -r. So if you were to square this whole thing, you would end up with I squared, it should be -3. I'm not sure why you would go through this process. In this next slide here, we're going to talk about the different forms of I. So I equals the square root of -1. If you were to square I, you would square this and the squares would cancel, would leave you with -1. If you were to cube it, okay, cube I, that would be the square root of -1 times -1. You end up with negative square root -1. Fourth would just be 1. I to the 5th, square root -1. I to the 6th is -1. I to the 7th is negative square root -1. And I to the 8th is 1. So what you can see here is a pattern. Basically, every multiple of 4 is a positive 1. So if I said I to the 12th power, that's a multiple of 4, and you would say the answer is 1. I to the 40th power ends up being 1. And this can give you a good basis of what you're looking at. So if I were to ask you what is I to the 50th, you would know that I to the 48th is 1, because that's a multiple of 4. I to the 49th is the square root of -1. Therefore, I to the 50th is equal to -1. So this is just a pattern. And the multiples of 4 is the easiest part of the pattern. All right, so now we're going to be solving these. And it's the exact same steps from 4.5. You have to isolate the power term. So first, subtract by 15 from each side. 2x equals negative 50. Divide each side by 2. Squared equals negative 25. Square root both sides. Please make sure when you introduce a square root, you add the plus or minus. And now you write this in terms of I. So, I'm going to go ahead and say that x equals plus or minus the square root of 25 times the square root of negative 1. Oh, but I think I said earlier that when there's a negative, just pull out the I. So when there's a negative in an even radical, you pull out an I. So this becomes plus or minus I square root 25. And then simplifying it, you should look at 25 and say, oh, I know that. That's 5. So it's plus or minus 5i. So your solutions are 5i and negative 5i. Let's take a look at guided practices for 1, 3, and 5. Number 1, x squared equals 13. Negative 13. So when you square root both sides, you end up with x equals plus or minus square root negative 13. Well, there's that negative again inside. So you bring the negative out, and you get plus or minus I square root positive 13. This is the standard form for your solution. Try number 2, or I'm sorry, 3. X squared plus 11 equals 3. Well, isolate the power term. Square root both sides. Introduce a plus or minus. It's the square root of negative 8. Well, that negative has to come out. So it becomes plus or minus I square root 8. Now you may think you're done, but please remember simplifying is very, very important. 8 is 2 times 4, which is 2 times 2. So we have one pair of 2's. So a 2 comes out. And you end up with plus or minus 2i square root 2. That is the simplified form. Number 5 has a few more steps this time. Let's add 7 to both sides. Negative 24. Let's divide by 3 because we still have to get the power by itself. And it's the square root both sides. And you will, of course, never forget the plus or minus. And if you notice, the square root of negative 8, we're remembering, is plus or minus 2i square root 2. All right, here's another one. Looks a lot like this. This time we're going to minus 13. And actually, you should pause the video and try it on your own. But if you don't want to, we're going to continue. 3x squared equals negative 36. X squared equals negative 12. So you square root both sides to get the variable all alone. And you get plus or minus the square root of negative 12. All right. Negative 12. Well, we bring the negative out, and it's plus or minus I square root 12. And then 12, you factor tree. Here's a pair of 2's, and a 3's left over. So it's plus or minus. The 2 comes out, and the 3 is left over. All right, sums and differences of complex numbers. To add or subtract two complex numbers, add or subtract their blank parts and their blank parts. So their real parts separately. Basically, you view the I, I'm going to say this, view I as a variable. Okay, for adding and subtracting, view I as a variable. Okay, this is an important piece right here, because if you view I as a variable, all you have to do is say, all right, 6, what they want you to do is combine, do the real parts, so a 6 and a minus 4, and then you're adding 3 minus 1. All right, but really you just look, what's 3 minus 4, or 6 minus 4? 2. And then 3i minus I, what's 3i minus I? 3i minus a minus is a plus. So 3, that's plus 4i. Down here, you're looking at the real parts. 2 plus 7 gives us 9. 5i plus negative 2i, that would be 5 minus 2, ends up being 3i. Let's look at 7. Guided practice number 7. 9 minus I. Right. Adding the real parts. This is a real part. This is a real part. 9 minus 6 plus, that's an imaginary number. That's an imaginary. Negative 1 plus 7. Or just look at them. 9 minus 6. Negative I with 7i. And that's pretty much how you do these. Look at it piece by piece, and you should not have any trouble. 9 is negative 4 minus 1 plus I. All right. So let's just write this. I think you should write this without any of the parentheses. So here's a minus 4. The minus gets distributed, minus 1, minus I. The minus gets distributed, minus 5, minus 9i. And now combine like terms. A negative 4 with a negative 1 with a negative 5 becomes negative 10. Negative I with a negative, that's minus 10i. That's pretty much it. That's adding and subtracting. You view it like a variable. Multiplying, you also view like a variable. But, and that's a big but, when you have I squared, you have to remember that I squared is equal to negative 1. So when you're multiplying, when you're foiling, 2 times negative 5 is negative 10. 2 times 2i is plus 4i minus 5i plus 2i squared. All right. So that's negative 10 minus I plus 2I squared. Remember that I squared is negative 1. So basically, this term right here, you get rid of the I squared and you change it to negative 2. You just change the sign. And you end up with negative 12 minus I. That's how you multiply these out. Let's take a look. Let's jump ahead to a guided practice like number 12. Number 12 is 3 plus I, 5 minus I. And what we're looking at is you're foiling again. 3 times 5, 3 times negative I times 5, I times negative I, right there. So like I said before, I squared part, you change the sign, and then get rid of the I squared. So I can rewrite this. I have to change the sign and get rid of the I squared. And now when I combine like terms again, you got that. So that's multiplying. Now, dividing complex numbers is a little tougher. This you have to remember when you did things like 2 minus square root 3. You had to multiply by 2 plus square root 3 and 2 plus square root 3 because you cannot have an imaginary number in the denominator. So what you're looking at, you're going to multiply the numerator and denominator by 2 minus I. And what that'll end up doing is it'll actually get rid of the I part in the denominator. When you do 2 plus I and 2 minus I, the inside, these are conjugates. The inside cancels out. So the inside cancels out. So all you have to do is fool the FL. Forget about OI. Don't have to do it. 2 times 2 is 4. I times negative I is negative I squared, which, according to this over here, change the sign, get rid of I squared. Change the sign, get rid of I squared. So that's 4 plus 1. So our denominator magically becomes a 5. The numerator, you have to do all parts. 6 times 2, 6 times I, negative I, 4 times 2, minus 4I squared. So the numerator becomes 12 plus 2I minus 4I squared. Remember that I squared is negative 1. So we simply change the sign and get rid of the I squared. Change the sign and get rid of the I squared. So it's 12 plus 2I plus 5. Well, 12 plus 5 is 17 plus 2I over 5. That's what this ends up equaling. All right, so we already did 12, so I'm not going to do 11, but I will go do number 14. I would make sure you have these steps in your notes. We multiply by the conjugate, 3 plus 2i. And again, the reason we do that is it gets rid of the middle part. It gets rid of oi, and you just do fl. So you end up with, in the denominator, 9 minus 4i squared. Now, remember, I squared, change the sign, get rid of the I squared part. So it's 9 plus 4. You end up with 13 as your denominator. Much nicer than the 3 minus 2i. The numerator, you have to FOIL. 5 times 3, 5 times 2i, 2i times 3, 2i times 2i, 4i squared. Once again, I squared is negative 1, so you change the sign. So let's combine some like terms and say to ourselves, well, you change the sign, get rid of I squared, so it's minus 4. 15 minus 4, and there's your answer. Oh, all right, some more for us to do. All right, looking at the real parts, 12 minus 16. Looking at the imaginary part, minus 2i minus positive 3i. So minus 2i minus 3i minus 5i. Let's distribute. That would be negative 36i minus 20i squared. Well, a negative I squared is negative 1, so we change the sign and get rid of the I squared. So that's an okay answer, but please, etiquette tells us it should be this. All right, let's do number 5 because it's adding again. 4 plus negative 6. 4i plus 3i. There you go. All right, number 4 is the most time consuming because you have to multiply by the conjugate of the denominator. It's exactly the same except a different sign. And the whole reason for doing that is it gets rid of the I, middle term. 3 times 3, I times negative I, and so on. 8 times 3 is 24. 8 times, that's negative 8i minus 12i plus 4i squared. The denominator is the nice part. It ends up being 9 plus 1 because it's the opposite. Change the sign, get rid of I squared. So now looking at here, 8i and 12i, negative 8i and negative 12i ends up being negative 20i. 4i squared, you change the sign and get rid of I squared. So when you're looking at this, 24 minus 4, you end up with 20i, or 20. 20 minus 20i divided by 10. And this is a completely acceptable answer. I will give this to you. All right. But the next part is, look, 20, 10, 20, 10. That can reduce to 2 minus 2i. All right. Those are the checkpoints. All right. So complex plane, remember, is an imaginary part. That's the BI. And the real part, that's the A. So this is positive, positive, minus positive, minus minus, and positive minus. So when you're actually graphing these things, a positive real is 1, 2, 3, 4. A positive imaginary, 1, 2. There you go. The plot start at the origin, move 4 right, and then move 3 up. To plot this other one, this is the real, and it's negative, so 1, 2, 3, 4, 5. This is the imaginary, so it's negative, so 1, 2, 3, 4. So you would move left 5, down 4. Please notice that anything on the real number line, when there's a number here, or here, or here, this means there is no imaginary part. Anytime you have something here, here, on the imaginary line, it means there is no real part. The absolute value, you've seen this already. To fill this in, hold on. The absolute value of a complex number is a blank real number defined by this. Oh, positive. Distance of z from the origin. All right. So basically, for a, 6 minus 8i, it's the square root of a squared plus b squared. Well, that's the square root of 6 squared plus negative 8 squared, which is the square root of 36 plus 64, which is the square root of 100, which is 10. That's pretty much it. This one right here, 6i, well, there's no real part, so it's 0. So that's the square root of 0 squared plus negative 6 squared, which is 0 plus 36, which is 6. So the distance is 6 units from the origin. Now the guided practice for these have us graphing them before. So 15 is 4 minus I. So the graph of that would be real 4 to there, and the imaginary negative 1, that's your first part. The distance, though, would be the square root of 4 squared plus 1 squared, which is the square root of 17. Now, the square root of 17 is not a usable distance, so you could probably say that this is approximately 4.1 maybe. I'm not quite sure what the square root of 17 is. Yeah, it's 4.1. So that means right here, this distance is 4.1 units. Number 17, 2 plus 5i. Well, the real part is 2, so it's right here. The imaginary part is positive 5i, so it's up here. So the square root of 2 squared plus 5 squared, that's the square root of 4 plus 25, which is the square root of 29. Now the square root of 29 is not a very nice number. It's about 5.4. 5.4, so that means the distance from here to there is approximately 5.4 units. All right, we're almost done. You just have to do these last parts of your note-taking guides. Let's graph them. 4i, look, there's a 0 is the real part. So negative 4i goes here. Find the absolute value. 0 plus negative 4 squared. The square root of 16 is 4. So 1, 2, 3, which makes sense. 2 plus 3i, that's 2 plus 3i. You end up doing the square root of 2 squared plus 3 squared, which is 4 plus 9, which is equal to the square root of 13. The square root of 13 is approximately 3.6. Distance from here to here, 3.6. From here, it's 4. The last problem, negative 3 plus 1 right here. So it's negative 3 squared plus 1 squared. That's 9 plus 1, square root of 10, which should probably be about 3.1. Might not actually be 3.1, but it's pretty close. 3.2. Okay, so I think you've seen enough. I don't want to keep you any longer. This is what we should be working on in class. Make sure you finish the guided practices, though. I did a lot already for you, but these are the guided practices. Good luck.